Variations, Part 3. In this video, I will introduce another type of variations. In our world, we have different kinds of equations. Some equations related to two variables only, but we found lots of equations related to more than two variations. For example, the area of triangle depends on base, variable base, b, and another variable is height. So a is equal to 1 over 2b times h. If the relationship between these two variables is multiplication, we will call joint variations. So we say a varies jointly at b and h. Joint at b and h. That means, okay, the relationship between these two variables is multiplications. Class practice. Write down the equations for the following variations with k as the variation constants. A varies jointly at x and y. So A is equal to k, x, and y. Because jointly, the relation between x and y is multiplications. Same, b. B varies jointly at x and square root of y. So b is equal to k x times square root of y. C varies jointly at x and inversely. Okay, remember, the second part is inversely at y. So C is equal to kx over y. This is some of example of joint variation. But one reminder, sometimes the question can change like this. I use this example. C varies directly at x. Although we do not have the word jointly, okay, we have C varies directly at x and y and inversely at y. But this example is also joint variations. So bear in mind, sometimes we do not have jointly, but if the description like this, varies directly at x and blah 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 blah, then that means x. The relationship is x times y, time over y. Let's see example 6.6. You can predict, because we have one variable, okay, k, variation constant only. So the question is similar to the previous one. Suppose z varies jointly at x and y to the power 3. Also, you can see the question will give you one information. What is the use of this information? To find the variation constant. Express z in terms of x and y. Step 1. Write down the relation between x, z, and y. Z is equal to kx times y to the power 3, where k is a non-zero constant. When x is equal to 2, y is equal to 5, z is equal to 500. You can find the values of k, the variation constant is equal to 2. Remember, write down the relationship, because I need to express z in terms of x and y. So this is the final answer. Part B. X is equal to 3, y is equal to 4. I want to find the values of z. Okay, this is z. Can we do amend it? So z is equal to 384. And you may do the problem exercise 7 and check your answer. Pause the video and check your answer later. Suppose p varies jointly at x squared and y. So p is equal to k x squared y. Give you one information, substitute into the equation. You can find the values of k is equal to 1 over 2. B, when p is equal to 75, x is equal to 5. Substitute it. Times 2 on both sides to eliminate these fractions, and divide 25 on both sides, you can find the values of y. Next page. Example 6.7. You can see the question type is similar to the direct variation and inverse variations. Give you the variation, the relationship between the unknown, and give you one information, ask you to find another variable. Second type of question related to percentage change. Same concept. P varies directly at x squared and inversely. Can you see? This time we do not have the word jointly, but also joint variation. Kx squared inversely at square root of y. I want to find the percentage change of P. Okay, P is our subject, so we do not need to make subject. Next time, if P is not the subject, you need to make the subject first. So P new is equal to K second, carry mistake. X increased 25%. Remember, it's the whole term of X increased 25%. So this is the new X. So this square, we also need to give the square for this 1 plus 25% over square root of y. And the new y increased 44%. So the new y is y times 1 plus 44%. And this square root, okay, this 1 plus 44 is inside the square root. This 1 plus 25% is inside the square. Then, same idea, I take out the original one. We remain 1 plus 25, that means 1.25 over square root of 1.44. It's 1.25 over 1.2. I do step by step. So 1.25 divided 1.2 is equal to 1.041667. The number is greater than 1, so I can change to the percentage increase format. It's 1 plus 4.17%. Then P increase by 4.17%.